the implied domain. So I'm looking, for example, at number 38. Well, okay, 38. The reason I'm starting with that one is because I think you know what shape that is, because we've talked about it a few times. What shape is it? A parabola. F of x equals x squared is a parabola, although it also has the plus 4. And one thing we'll be talking about soon is what does that do to the parabola? Well, if you added 4 to everything for the output, it's going to raise it. But it's still a parabola. And a parabola, you're allowed to put in any number you want, okay? And so when I do 38, well, I'd say, hey, the domain for number 38 is all real numbers, okay? So here I'm at section 1.4. Number 38, the domain, well, it's any real number, so it's negative infinity to infinity, okay? So I need to find one more interesting, something that has a domain that is not negative infinity to infinity. And so 42 is a nice example of that. 42, well, it's the function f of x equals 2x over x squared minus 3. All right? Now, when I do these problems, I'm trying to find the domain. I want you to expect that most numbers are in the domain of a function. Could I put a 0 in for x? Sure. Could I put a 1 in for x? Sure. The only time I'm going to be in trouble with this kind of function, by the way, this is called a rational function, or if you don't like that name yet, it's a big fraction, right? The only time I'm going to be in trouble with this big fraction is if what happens? If what equals 0? If the denominator, all right? So here we have trouble if the denominator is 0. So if x squared minus 3 equals 0, which would mean x squared is equal to 3. So how many trouble spots are there? 2. What are they? Plus or minus the square root of 3. Okay? So this is trouble, remember, if that happens. So when I want to list the domain, I guess what I want to do is I want to avoid those. And so I think a nice way to say it would be you're going to go from negative infinity up to, say, negative square root of 3. But I'll put a parentheses. Why? Why did I put a parentheses? Do we want to include negative square root of 3? No, that gives me trouble. See, the picture, maybe the picture is easier. Start with the picture. The picture is I don't want to include negative square root of 3, and I don't want to include positive square root of 3. But other than that, I can include anything for an input I want, all the way out to negative infinity or all the way to positive infinity. And so with that picture in mind, I want to write it, say, in interval notation. Maybe what I'll do is I'll put a union symbol here, right? So I go from negative infinity to negative square root of 3. What's the next interval that I want to have? Up to square root of 3, and that should be an open interval. We want a parentheses. Let's union that with, say, square root of 3 comma infinity. Okay? So I think that serves as a nice example of you know, a domain that's not all real numbers. Barbara. You want me to set it greater than or equal to 0? Oh, okay. So I guess it depends what kind of function you have. Denominators are trouble when they equal 0. But you're allowed to put a negative number in a denominator or a positive number. I think what you're thinking of is a square root function. So for example, something like 48 is a good example. I guess I'll finish with that. 48, you have f of x equals the square root of 7 minus x over x squared plus 1. Okay? Now, can you give me a number that would be a bad idea to put in for x? Go ahead. 8. You guys see why 8 is no good? The denominator's fine. Where's the problem? If I try to compute f of 8, what happens is I get the square root of 7 minus 8. And what do we... That's not... Yeah, that's imaginary. We have a rule for this class for a while, and that's keep it real. Okay? All right? So, for now, we will get to complex numbers, but for a while, let's keep it real, and so we're going to stay away, and let's instead say that the domain should not include 8, for instance, right? I mean, I know that 8 over here is no good. That's trouble. So I'm not going to include 8. Hey, what about 7? Can you include 7? If I put in a 7, well, it's either yes or no, right? But let's try. Well, what is the square root of 0? That's the question. Is that true? The square root of 0 is 0? Here, what's the square root of 16? Because why? 4 squared is 16, right? When we say square root, that's what I mean. So let's see if it works. Square root of 0 is 0 because 0 squared is 0. I guess that's okay, right? But we understand that with negatives, we're out of luck. You can take a square root of 0. So I guess what I'll say is the domain would be, well, you're allowed to include 7. What other numbers am I allowed to include? Anything less than 7, right? So anything over here is okay. Even really negative numbers are going to make that positive. So your domain would be from negative infinity to 7, but you want to include 7. By the way, sometimes you have to also worry about the denominator, right? Because we can't make the denominator 0. But I'm lucky in this problem. That's one of the reasons I picked it. What's lucky about this denominator? There's a plus 1 there. And what do you know about x squared? That's always going to be 0 or greater, so the denominator here is always positive. You guys see that? But you can imagine examples where that won't happen. And you'll see them tonight, I'm sure. Okay.